Welcome back po, dear guests, teachers, admin, and students. We hope that you filled your tummies well and may we have enough energy to absorb the final topic for this program. Kayo, Sir Payen, anong ulam nyo kanina? Ako, tawag nito? Ah, arroz a la cubana. Si Sir ninyo ang nagluto, hindi ako dahil nag-MC ako. Ayun.
Ayun ma'am, ako walang magluluto eh. Bumili lang ako.
Ano ulam nyo, Sir?
Shanghai. Naubusan ako ma'am
Okay po.
nung mga karinderya. Ayan, sana po lahat din nakakain na, may energies na sana tayo para makinig sa last topic natin for today. Ayan. So again, we welcome you for the afternoon session of the Quezon City Science High School Senior High School First Virtual Research Capstone Orientation with the theme An Effective Guide in Conducting Research Capstone in the New Normal. I think the dessert we should have is the last topic, no? That will be
Yes.
discussed today. Yeah.
That's great, sir. Before we continue our discussion, again, we are reminding everyone to make sure that you are already registered for this session. The link is given in the chat box. Andun na po ba, sir? Ayan. So, may bagong link tayo. Ayan. Yan. Next, please mute your mic throughout the session unless you are given the permission to speak. You are allowed to message in the chat box if you have questions, clarifications, or concerns. This will be relayed to the main link by your class advisor, and the speakers will have the time to answer in it in the open forum. And make the content of your chat or comment relevant to the session. And lastly, sit back, be comfortable, and listen attentively as the speakers shares their expertise in the topic. And for the last speaker, Sir Payen, may you introduce our last resource speaker?
Sure, ma'am. Ayan. Our last resource speaker for our topic, How to Communicate Scientific Findings, is a faculty member of the Science Education Department in De La Salle University, Manila. He obtained his Doctor of Philosophy in Science Education with specialization in biology in the same university as a Department of Science and Technology Science Education Institute Scholar under the program National Consortium for Graduate Science and Mathematics Education. He has been affiliated with several academic and research professional organizations, including the Biology Teachers Association, National Science Teachers Association, the National Research Council of the Philippines, and the International Academic Forum. He has published research works indexed in the ISI and Scopus Journal and participated in various conferences here and abroad. His research interests include the social justice in curriculum development, participatory and educational action research, democracy and equity in science education, and integration of technology across learning modality to improve the teaching of science. He was involved in the development of the basic science education curriculum of the Department of Education, where he used to be the senior curriculum specialist for science education and research. Some of his projects included were development of national historical curriculum, rabies education curriculum, climate change curriculum, and antimicrobial drug resistance curriculum. Ladies and gentlemen, let us welcome with a virtual round of applause Dr. Dennis Davy R. Erabo. Good afternoon, sir.
Hello everyone, good afternoon. Can I be heard?
Yes po, sir.
Yes, sir. Loud and clear po.
Okay, thank you very much for the affirmation. So allow me to share my screen to all. Okay, so before I start, I would like to inform everyone that I am situated close to our window. So most likely you would be able to hear some ambient noise coming from the outside. I situate myself here so I can hear or I can receive a very good internet connection. And whenever I would have an intermittent connection problem, allow me to disable my camera so to facilitate a seamless presentation. Okay lang po ba?
Yes po, sir.
Okay,
Yes,
thank you
sir.
po. Thank you, everyone. So, once again, good afternoon. The title of my talk is Communicating Scientific Findings. So, in our daily living, we are being bombarded by convoluted information and data. And more importantly, we should have realized that research is a lifelong skills. And through this data, we would be able to become informed decision maker and generate sound decision. For this presentation, I'm going to talk about the different data classification, findings as a source of information, a little discussion on scientific integrity, and let me also share with you some of the tips that I personally utilize when I do communication of my research. So these tips could be applicable across different communication modality. So let's begin with data classification. So at first, you might want to ask, what should be communicated? So basically, we communicate information and data. So there's a clear line between data and information. Data can be drawn through empirical evidences, and information can be a theory or it can be a narrative that can support our data. And aside from that, we also have to communicate our best practices, our ethical practices, and our professional values when we are communicating the result of our paper or of our findings. So let's begin with data. So when we talk about data, we have assumed facts, no? So facts can be tested by its validity, and facts can be determined by a certain value. And as I said, it's something that can be quantified. It could be also described qualitatively. So it could be in a form of character or symbol. So both quantitative variable and qualitative variable can be considered as data. And these information can be derived from observation. So when we observe, we aim to generate evidences that we actually see, feel, touch, smells, or listens. No, so this is how we gather evidences. More importantly, we need to realize that we have to utilize multiple organs in order for us to provide a clear picture of a social predicament. A social predicament can be in the form of our research problem or research interest that we try to solve in our study. So data is very helpful because data would actually allow us to illuminate the condition or the social concern. Again, when I say social concern, sometimes it can be a social problem or it could be a researchable problem. So it all begins with observation, where we have engaged all of our senses to generate empirical evidences. We do induction and deduction, which I'm going to talk in the next slide. And then we do testing. Testing is more explicit for positivist research or research that does a lot of data reduction and involving scientific method and um, empirical empirical analysis. And then from this, we can do some evaluation and proceed again to observation. And this is the reflexivity of the data that we call out from a simple observation. So earlier, I said that the second and the third step of data generation is through deduction and induction. So deduction can be done through through facilitating a simple idea, and this idea can be verified through observation to generate a sound conclusion. While induction typically begins with observation, and then this is being backed up by our analysis of the empirical observation, why it happens or how things happen, and then it can actually create theory. So aside from data, we also communicate information. Information is very relevant because data alone cannot just provide clarity in terms of the context of the phenomenon. So information describes the relationship among the data or among the variables. So information is an inferred evidence from the actual observation. So sometimes inference can be subjective, but when inference can be done through a series or a strong protocol, so then it could be systematically done to generate an information. Information is also what we mean by the meaning of the data. When we call out all the data and when we try to organize and synthesize the information from them, we can generate a meaningful information that would illuminate the context of the research objective or the research problem. So information can be derived cyclically or iteratively or linearly. No? So when we derive information iteratively or cyclically, we begin with observation, and then our observation sometimes can be modified in order for us to adapt to a certain theory. And then our theory is the ones that we use to be guiding us in the development of our hypothesis. And then from the hypothesis, we can build our research design, whether our research design is a positivist one or interpretative or critical one. Our hypothesis is actually the ones that providing us clear direction in order for us to generate information that would be able to provide answer or solution to our researchable question. So from here, we can actually create another series of experiment or another series of observation that would be done to ensure systematic elicitation of evidences pertaining to the occurrence of such problem. So aside from the cyclical or iterative, information can be through a linear process. So information through a linear process is typically done through scientific method, where information can be elicited through observation or using the senses. And these observations sometimes can be verified by our theory on the condition. And these could actually help us to determine whether we have a proper prediction or whether we are oriented towards a proper or a good claim on such problem. And then from that, it extends to the generation of evidence and reporting of results. So you see, whether it's iterative or linear, information cannot just stand as information. It should be taken from empirical information, which being supported by data or several data. So there's a clear difference between data and information, but both of them are very essential, especially when we are communicating our research finding. Data can be determined as raw form of information, while information is something that has already been processed. Sometimes there may be discrepancy between processed information and data, and sometimes information alone without data can be hardly understood because through processing of data, sometimes we have already concealed primary information that would provide the ultimate source of the explanation of such phenomenon. Data is difficult to understand, especially if it includes a lot of analysis or if it has already or if it is not yet analyzed, no, or if it's properly plotted or kept in a journal. So what we have to do is to do a lot of data reduction and data generalization, but that is only exclusive for positivist research. The other form of research paradigm sometimes does not really require generalization, especially for interpretative and critical research. Information is easy to understand because it is rooted from the outline of our data. Data can be complex and vague because sometimes empirical data should be processed first or should be organized first. And sometimes we have to eliminate also similarity in terms of the occurrence of the data in order for us to make it simple and clear. So information is always simple and clear. So at this point, you might be asking, Hello?
Yes, sir.
Hello? Can I be heard?
Yes po, sir.
Okay. Sorry. Hang on. Can you see my PowerPoint?
Yes po.
Okay. So I disable my camera. So data can be qualitative or quantitatively generated, no, empirically. Sometimes qualitative data is more rich and more interesting over quantitative, and sometimes quantitative data can be seen as more objective over qualitative. But let's focus our attention first in the qualitative data. So qualitative data sometimes can be named as categorical data. There may be two examples of qualitative data. So these are nominal data and ordinal data. We're going to tackle them one at a time. So for nominal data, typically the word nomen here describes that this kind of variable is something that is named, no? So Latin for nomen, and it means named variables. Named variables can also be a noun, or can also be a phrase, or can also be a sentence. This named variable typically is a description of the phenomenon. So it's qualitative because it utilizes letters, phrases, clauses, and it's highly categorical in nature. It lies at the core of the storytelling, anecdotes, um, shared experiences, and sometimes it could also be culturally embedded. Nominal data can be facilitated through asking and writing. What I like about nominal data nowadays is that it's easily uh, to generate information through nominal data. Through different platforms, we can ask questions or we can interview someone, and there's a lot of algorithm that can actually provide us transcript of what we have captured, whether it's a context of a discussion, a discursive analysis, or it could be an artifact. So here are some of the sources of a nominal data. Typically, for qualitative research, a researcher may have to be immersed to a certain situation, and this is very exclusive to sociological, anthropological, and social sciences research. They have to be immersed for at least 6 months to a certain situation where they are gathering stories, anecdotes, experiences, narrative, etc. Observation can be depicted and can be captured through several techniques, but that could be a different workshop or a different webinar. Nominal data is facilitated through individual or group discussion. So individual and group discussion could actually provide us a varied experience, no? A varied experience that provide extension and explanation of such phenomenon. Sometimes uh, when you are after a certain variable, sometimes it lacks explanation and it limits um, to a certain point that this variable can manifest something. But through nominal data, we would be able to extend and expand information through asking and through discussion. Nominal data can also be generated through document analysis using a certain protocol. We can identify what document could be utilized for a certain cause. For example, if you're looking for a documentary analysis on different policy on education, you need to determine a certain unit of analysis where you're going to look after while you are scanning and skimming some of the data. No? And then aside from that, nominal data can be from stories and from anecdotes. So if you want to talk and if you want to listen to people, and if you are more oriented toward humanistic and social science individual, most likely you are oriented towards generating nominal data. So nominal data typically done through thematic analysis. And thematic analysis should be processed further in order to present information accurately and with validity, no, and trustworthiness. So you transcribe the data at the beginning, and as I have said earlier, there are a lot of algorithms that can transcribe data, can capture the data. You define the unit analysis, whether you are looking only for a certain condition where you are interested at, a certain model, a certain theory, which can affect the rest of the variable. And then from that, you expand it through thematic analysis, and then you write the result. However, it's not simple as what you can see on the screen. Through thematic analysis, normally you identify a lot of codes. Codes can be transcript, or codes can be phenomenon that can be taken from the immersion of the researcher in a social condition. Codes can be organized through subcategories where there's a lot of data reduction to happen, and sometimes subcategories should be further lumped in order to make a category. So category is an organization of your subcategory, but in categories, you may be able to determine what may be similar in subcategory and what may be different in subcategory. And then to organize your similarity and differences through your category, you can actually create one holistic theme. This holistic theme typically is the topic sentence that you normally explicate when you are writing your research result. So some of the examples that we utilize when we are presenting nominal data nowadays is the word cloud. I don't know if you can see a word cloud. Most likely some of you here have experience in dealing with voluminous data and have to process it through a word cloud. You can see different colors, different magnitude, and different position of the context of the statement. Probably this refers to the pandemic, no? And as you can see, those wordings with higher magnitude may indicate uh, a frequent response coming from the participants. And sometimes word cloud can be done with a lot of variation. So you can formulate a lot of themes from word cloud, etc. It can be embedded into a lot of software, and I think word cloud nowadays is being considered as one of the strategy in order for us to communicate the information through frequency of the results based on a feedback. Aside from the word cloud, we also utilize selective codings or coding system. There are a lot of coding system. The most commonly used is selective codings. There are also close coding, actual coding, and open coding. But for your level, most likely I would like to introduce to you the use of selective codings. Selective codings utilizes certain segment of the statement from the participant that could provide an illumination of the context of the problem, whether it could refer to as a feedback or it could be a part of a dialogue or conversation excerpted from this conversation can actually provide um, a varied and an enriched discussion of quality of the information. So again, for nominal data, we are looking after enriched information. We are looking for variety of information. We do not aim to generalize information or to reduce them, especially when we're using selective codings. But it's a different story for thematic analysis because sometimes through data reduction, we can lump ideas based on categories and subcategories. No, it could also be a form of data reduction, but typically the goal is you have to combine those similar ideas. And then aside from that, we can also use pictograph. This is the most common error that I notice when I check SIP when they are presenting, for example, a nominal data. Most students do not use pictograph as a data representational tool in order to summarize the information. It's exclusive for nominal data because what you can see here, male and female refers to name, no, or label. But the percentage here is sometimes the distribution of the frequency of male and female. But if your data is more oriented towards the individual or the respondents who partake a certain activity on a certain research endeavor, most likely the use of pictograph using pie chart can be a good data representational tool in order to provide clarity in terms of the context of the data. We can also use actual photos for nominal data. This one is a picture of a karyotype, which we have did when I was taking my PhD. We went to St. Luke's Medical Center and we did karyotyping activity. Um, I feel so happy because the scientist in resident in that hospital is the only karyotype expert in the country. So we did a lot of karyotyping activity, and these are just actual photos. After you have organized, for example, the different chromosomes, you would be able to determine what may be missing or what may be structure that can be deformed or um, deleted or can be uh, transferred, no? And through actual photos, sometimes you would be able to provide primary information that reveals abnormality. It also reveals lacking information. It reveals missing information that sometimes very critical in decision making. We also use coding system when we are referring to nominal data. Through binary coding system, sometimes we can input algorithm or binary codes in a software that can create a more and a strong organization of variables. So in this example, you can see here different organisms vis-a-vis with their characters, and I have coded one to indicate present and 0 for absent. And when you use a code, for example, 0111111, you can actually create another data representational tool. No? But through chart, you can provide information such as coding from your variables. So at least when you do this, you are also providing concise and brevity in terms of the information that you are sharing with your reader. The goal is to inform, no? So if you do not organize your data, most likely you may not be able to inform well. So aside from nominal data, we also have this ordinal data. A notch higher from nominal data is ordinal data. It requires arrangement of the variables, no? Sometimes ordinal data can be married to quantitative value or variable in order to make it more explicit or to make it more meaningful. So ordinal data requires organizing skill. So that's why research is a lifelong research or is a research skill. It requires several manifestations of scientific processes involving organizing. So ordinal data requires ability of the researcher to determine which trait or traits can be similar or different and put together those similar and different and observe pattern, observe trend, no? And through that, you would be able to determine such order. So one of the classic example of ordinal data representation tool is what we call a pie graph. In here, you notice that this has already been uh, combined with quantitative data to see certain ratio of the different fruits. And through this, you could easily discern that grapes may be bigger in terms of proportion to other fruit. So pie graph is a very powerful ordinal research communication tool. By just simply glimpsing on the data, you can see fraction that can provide explanation why an event happened that way. So we also utilize table for ordinal data, and typically for a table, what it tries to provide is to organize data based on the frequency and based on the percentage distribution. Normally, a table is utilized for bivariate analysis, where you have your independent or dependent variable, or both dependent or both independent variable. And typically, this one is done for a purpose of quick analysis of the distribution of the findings. No? So through this table, you can see the distribution of the latent class based on their gender. Ordinal data can also utilize chart for presentation. Chart is a very important tool for ordinal data because you can see here similarity based on the variable that you have combined. For example, if you have homologous recessive trait and a heterozygous trait, no, you can easily see here through assortment that it can lead into two dominant heterozygous trait and two homozygous recessive trait. So through this chart, you can infer certain ratio and probability that when a certain variable may be combined, it could yield into such offspring. Okay, we also utilize cladogram for ordinal data. Cladogram sometimes can be generated from binary coding or can be interpreted based on the algorithm that you can display in a system. And through binary code, sometimes you can easily lump information which provides similarity and isolate information which can be far different. No? In this example, you can see that the most advanced species is the human. The human possesses all the traits which may be present to gorilla, tiger, lizard, salamander, shark, and lamprey. And as you can see, as the hierarchy develops, another trait also observes in in the in the organism. I'm sorry for the ambient noise. You can hear barking dog. So this one is a mass spectrophotometry. This one is an actual reading. This is also an example of an ordinal data. Although sometimes you may be asking, because this is an actual reading or an actual photo, this could also be nominal data, but sometimes the peak here, the peak can also refers to organization of the similarity of the variable, no, that appeared in the context of spectro testing. You can see the variation of the different colors here as indicative of the readings of the test sample. So those who are in those with peak most likely can be inferred with a certain frequency based on a certain sample test. So this one is an actual reading which can be utilized as a data representational tool. Okay, so I think I'm done with the qualitative data. Let's proceed with the quantitative data. Quantitative data, as the word implies, it's something that can be quantified. The goal is to reduce data to generalize information, and to generalize information sometimes eliminate outlier or those who are not really good fit for the data distribution. Quantitative data can be discrete data or can be continuous data. So let's begin with discrete data. So if your ordinal data is a notch higher than your nominal data, your discrete data is far higher. But this is only just if you're referring to your test statistics. But when you're talking about a different research paradigm, nominal data can always be higher than discrete and continuous data if you are in the spectrum of interpretative and critical research. But for positivist research and requiring generalizability research, this is the third level of the data. So you have named your variable, and then you have ordered them, and then you put equal interval amongst them. So when you put equal interval, basically zero is always arbitrary, and the distance amongst variable is very meaningful. So discrete data requires generalization. So strategies involving the use of statistical analysis may be required for quantitative variables, particularly to a discrete data. No? So as you can see here, we have this measure of central tendency, which can be either your mean, your median, and your mode. You can see a normal distribution here where your mean, median, and mode combine together. So it forms a normal distribution or a bell curve, which is symmetrical. What you can see on the left is in symmetry with what is in the right. No? So this is in harmony with your central tendency. But also, aside from the position, you also consider the dispersion. So the dispersion sometimes can be relative based on the distribution of your normal data. Sometimes your dispersion can vary based on the skewness of your bell curve. But your dispersion should always be in harmony with your central tendency. So that's why in statistics, we always pair measures of central tendency to variability and dispersion. So for this data, typically we look for position. Position sometimes is an indicative of most frequent or or commonly occurring result, no, or data or feedback. So sometimes we can use line graph for a discrete data. You can see here a chart uh, of the information, and you can see here distribution of the results, no? And in this distribution, you can see it creates a graph. It creates a line graph, no? Sometimes data analysis can be very tricky, so it requires skills, and these skills should not be limited in the confined um, variable, but more importantly, it should also be on principle, no? Why you have to use your mode, your mean, and your median? For example, in analyzing the result of this distribution, you really have to think which provides a more significant or interesting data, no? Sometimes it depends in the context. So that's why the data alone cannot be enough, and it should always be supported by information. So you can at least explain through information or through narrative why your data distribution appeared to be like this. Sometimes we can also use chart for discrete data where we can combine our mean with our standard deviation. The median should be compared with interquartile deviation or interquartile range, while if you have the mode, you can also combine that with the range. No? So through the chart, you can see here position and variability. So chart is commonly used, especially for social sciences and for basic science research. So aside from the position, variability and skewness can also depict a story, no, based on the test specimen or based on the phenomenon that you're trying to observe. You can see here a normal distribution, but you can see here also a symmetrical curve of um, data, no? And sometimes when information may be skewed to the left or skewed to the right, they have a certain value, and sometimes you are after that certain value, and you need to analyze that accurately and precisely in order to ascertain whenever you are ascertain about the accuracy and precision of your data. Sometimes you always have to check to standard measure of analysis. So that's why we have standard p-value or whatsoever, no, to determine a certain test of inference if you are not sure, etc. Histogram can also be a useful tool in order to provide clarity in terms of the context of the information. This is a discrete information. You can see here distribution of binomial and normal distribution, and it tries to form a symmetry. No, you can see also equal interval. And then aside from that, we can also utilize scatter plot. Typically, a scatter plot is um, utilized for correlational analysis, where we are very much interested about the association of the two variables, whether we're referring to both dependent, both independent, or a combination of dependent and independent. No? In most cases, when you combine your dependent and independent variable, it forms a strong connection, and there's a strong value. The value can be inferred based on the analysis that you have incorporated in the test. It could be a certain R value or a raw value, or it could also be a certain product value. So a scatter plot provides you a linear distribution of your data, and those commonly situated in the center of the distribution sometimes are the most associated ones. So of course, if you have scatter plot, you can also utilize line graph for correlational analysis. So this is just an extension of a scree plot or a scatter plot. So a line graph can also depict uh, condition or probably prediction or proportionality, no, or relationship. So this one you can see direct relationship of the two variables. As your x increases, your y also increases. But more importantly, you can elaborate what makes the distance between the male and the female, since both of them are directly proportional. No, so that's the story behind your information. So the highest form of data is what we call continuous data. Highest form in the sense that we're talking about positivist research, but this is equally important as of nominal data and or other categorical data. Continuous data in positivist research considers absolute zero aside from the name, the order, and the interval. No, zero exists, and similar to discrete data, it generalizes the data, and it has a lot of data transformation, and it has reduced several information into one. Typically, continuous data is a unifying strategy of data distribution. So, a knowledge about data science may also require skill, not only in statistics, but also consider those phenomenon that derived from empirical observation and combine them as one. So typically, we involve test hypothesis if we're referring to continuous data, and there are a lot of test hypotheses. Sometimes the goal is to reject our null hypothesis, and it depends on our aim and it depends on our design. Sometimes we look after the alternative ones, or sometimes we try to determine also a certain rejection value. No? For those who may not have heard a certain rejection value, this is a critical portion of your data distribution, by which any amount or any data that can exceed or um, can be beyond the critical value can be a decision by which your null hypothesis can either be rejected. No? So we can also utilize comparison of multiple means. When you do comparison of multiple means, most likely you consider multiple position and multiple variation. So multiple variation and multiple position requires testing of variance. No? So that's why we have this analysis of variance. Before, when I was taking my master's, it feels like feeling ko ang galing ko about stat or whatsoever. But when I did my PhD, the beginning course for advanced statistics is multivariate analysis. So this is just exclusive for bivariate, but if you are situated in multiple variables, and if you are confronted with multiple analysis, sometimes it's really hard to play with the data, especially if you do not practice the analysis for quite so long. No? And as educators, sometimes it's not really as interesting as talking to people, talking to students, determining their problems, their issues, developing intervention or whatsoever. So, but anyway, for continuous data, typically we utilize table that indicates all the variables in comparison with all the models and the mean and the location and the variability and the test. No, you can see something like this for APA 6th edition. You put your table on top and then you put here an annotation. So this is basically to determine which among the tests could actually provide relevant information that can either provide a support on your firstly developed hypothesis or probably a theory. So aside from table, we also utilize chart. I think you are all familiar that chart can be very flexible, and as we have started our discussion, we have been utilizing chart from the very first type of the data. No, the chart kasi could actually uh, provide all the information from all the sources and the variables and actual values and actual readings. But the most tricky thing is if you do not know how to read the chart and at the same time if you do not know how to appreciate certain value. So that's why for those who are at this level, it's really an imperative that you should have at least your statistics in order for you to really unify all your observation or all your empirical observation. Okay, so I think I'm done with the first part. Let's move on to the second part of the discussion. So when you have the data, it's very important that this data should be extended into narrative, and at the same time, this data should be utilized as an empowering agent in order to provide a clarity in the context of a social condition. No? Always